So we have a way of force, we have a bargain. Hunter purchases a gold crown at a flea market. Okay. After she gets home, she hangs the crown from a scale and finds its weight to be 7.84 Newton. Okay. Then she weighs the crown while it is immersed in water, and the scale reads 6.86 Newton. Is the crown made of pure gold? So for this exercise, we need to establish or separate the information. Okay. So to separate the information, we're going to consider the medium at which the crown is placed. Initially, it is weighed. The crown is weighed here in air. Okay. So in this situation, the fluid, even though air is invisible, okay, air is considered to be a fluid. So in this case, we have the object that is in air. Air is going to be the fluid. Okay? Now, the second situation occurs when she puts the crown in the fluid. Now, the fluid changes from air to water. Okay? So this is the situation 2. The fluid 2 now is water. So when we have objects that are measured in air, we're going to consider this in air to be the actual, okay? The actual, in this case, the actual weight. And in water is going to be, or in the fluid, in the second fluid, okay, it's going to be the apparent. Now, after you have established the two situations that you have for the wire force, what you do is, okay, we write the data. We write the data, so we say, okay, from this crown, Bethel, are you there? Orwell, are you there? From this crown, apparently it's gold, okay? So the material of the crown is gold, but we are not sure, okay? We are not sure if it's gold. That's what we're going to find out. So we need to know if it's real gold or not, okay? Now, you know that the actual weight is the weight in the air. Okay, so I'm going to put my actual to be 7.84 Newton that the problem is giving me. And I will put the apparent weight. This is the weight in the fluid, inside the fluid. It is 6.86 Newton. Okay, the question is it gold? Explain. Now, to know that, we need to see, okay? We need to see the substance, okay? Remember, density is related to the object's material. So the problem is asking me if it's gold. To know if it's gold, I need to know the density of gold. So I will put this extra information here. The density of gold, according to the table, is 19.3 times 10 to the third power. And I don't forget to write the units, kilogram per cubic meter, okay? Now, to know if it's real gold, what I'm gonna do is I need to compare. I need to compare the density of gold to the density of the real object. I mean, if I really have to compare, I need to know the data, okay? I need to know the data. So let's see. Now, what is the situation that you have? How is the crown? Is the crown floating on the water? Is it submerged? Or is it partially submerged? Where do you find that information? Take a look. Sample problem A. It says, then she weighs the crown while it is immersed in water. So the situation that we have for this object that is immersed in water is object submerged. So what is the equation that we use for objects that are submerged? How can we calculate the buoyant force for objects submerged? No one? Okay, the buoyant force for submerged object, I gave it to you. It is the mass of the object times gravity. It's not too hard, okay? Sorry, I got confused. For objects submerged, sorry, I got confused, is buoyant force. The buoyant force is equal to the weight in air. That is, the weight in air is the actual weight, and you will subtract the actual weight from the way that it is submerged. Okay, sorry, that is for submerged object. I was telling you the one for floating objects. Actual is in air, and apparent is in the fluid, or in this case, in water. Those are the two substances that are related, okay? Air and water. Remember, air in the top, water in the left. Okay, those are the two substances. So, I'm gonna erase it because it looks like a division, sorry. Okay, so the actual is in air and apparent is in water. So what you have to do is just subtract the 7.84 Newton in air minus the actual, that is 6.86 Newton. How much is this? This is
negative 0.84.
It can't be negative.
0.98 Newton.
0.98 Newton, positive. Okay. From this, you can move on to the next step. And the next step is the one I call the useful formula, okay? Now, what do we do in the useful formula, okay? So in the useful formula, we compare or we relate densities and weights, okay? So I will relate two densities. The density of the object divided by the density of the fluid in which the object is submerged. And then in the other side, I will relate the weight, okay? The weight, the actual weight of the crown, and I will relate, the weight of the object and the buoyant force, like that. This is the useful formula. Now, what do I need to know? I'm interested to know if the object is gold. But tell your camera, please. I'm interested to know if the crown is made of gold. So, what is the crown? Is the crown the object or is the crown the fluid?
The object.
So the crown is the object, which means that I need to know the density of the crown. So I'm going to write it here. The density of the crown. Crown is the object. And what is the fluid? And what is the fluid in which the crown is immersed?
Water.
So you need to always establish this. What is the object and what is the fluid? In this case, water is the fluid. So we say, I will isolate for the object, okay, density of the object. So this density of the fluid is dividing, okay? This is making a division. So when you move it from to the other side, it's going to be doing a multiplication, okay? So isolate for the density of the object, and you will have weight of the object times density of the fluid divided by the buoyant force. Now, what is the density of the fluid? I didn't write it in the data. So the fluid is water. So the density is, according to the table, fresh water, okay?
Yes, I had that question. So fresh water is normal, right?
Yeah, like normal water, water from the faucet, or normal
Okay, thank
water
you.
from the river. Okay, that's fresh water. Just if the problem tells you that is in the sea, for example, you're going to be using the other water. If not, density of water, it's going to be 1 times 10 to the third power, or directly you can write 1,000 kilograms per cubic meter. Okay, so right now you just put in the givens the weight of the object, that is the object, this is the actual weight, okay? It's going to be 7.88, 84, sorry, I guess. Yeah, 7.84. Density of the fluid, that is water, 1,000 kilogram per cubic meter. And this we're going to divide it by the buoyant force, that is 0.88 Newton. How much is this? How much is this?
8,000.
8,000. Okay, here newtons and newtons are going to be canceled. So the final units are gonna be kilogram per cubic meter. Okay, this is the density of the object. Now analyze the answer. Remember the question was, is the crown made of gold? So let's compare with the density of gold. Are they both densities the same? Is it the same density?
No.
So you're going to write, okay, density of gold is 19.3. I truly hate this, but I find it useful sometimes. Okay, so 19.3 times 10 to the third power kilogram per cubic meter. How much is this in, I mean, with all the digits, it's going to be 19,300, okay, kilograms per cubic meter. So now that you have in the same units, you can you can compare 8,000 and 19,000 is not the same, okay? So the density real object is 8,000, sorry, kilogram per cubic meter, is not equal to the density of gold, that is 19,300 kilograms per cubic meter. In conclusion, is the crown made of gold? Yes or no?
No.
Okay, just by comparing the data, okay, just you see it's not the same number, so it cannot be the same substance. So you can see it's not made of gold. Now, if I tell you to what substance the real density is approached, to what substance is approached 8,000?
Iron.
Okay, so you can also write that information, okay? Iron is here, and it's not the same, but it's close enough, okay? So we say, you can also write that the crown is more likely to be made from iron than from gold, because you are comparing the data, okay? So iron is a lot closer to the real density of the object than gold. It can either be mercury, because mercury is far different, okay? But it could be iron. okay? Or it could be an alloy, but it's closer, okay, to be iron than gold. A lot closer, okay, than iron than from gold. So to answer the question, is the crown made of pure gold? No, not made of pure gold. That's not even close to be gold, okay? So it is iron, probably just with golden paint in it. So take a look. In this kind of exercises, we are not just solving and giving a data, no. We have to answer a question. That's what we did. Now for this second exercise, wait. Okay, for this second exercise, what we have is a piece of metal, okay? A piece of metal weighs 50 Newton in air, 36 Newton in water, and 41 Newton in unknown liquids. Find the densities of the following: the metal and the unknown liquid. So you have to imagine, to picture in your mind the situation. We have the piece of metal that is in air, in water, and in unknown fluid, okay? So I'm going to put a picture for each, okay? So you have in air, just a little piece of metal, okay? That is being lifted, okay? And it measures 50 Newton. Now, when you put it inside water, it has buoyant force. So the weight now is not 50 Newton anymore. Now it is 36 Newton in water. And the other situation is you put the piece of metal again inside of a fluid, and now it weighs 41 Newton, but it is unknown fluid. This is what I do in the first place to have a better picture of what is going on in the problem, okay? In both situations, you have buoyant force, okay? Because you put it inside a fluid. Now, in air is what you know to be the actual or real weight, okay? Now, knowing this, you're going to get the data. Well, the data is placed in the pictures. I'm not going to write the data because it's already there in the pictures, okay? Now, in the first part, it says that I need to find the density of the metal. The density of the metal is unknown, okay? So, I can picture two situations for this exercise. When the object is inside a fluid, how do we call that situation? Floating, submerged, or partially submerged?
Submerged.
So it is submerged. And the other situation is the same, is the same piece of metal, but again inside in fluid, so it's going to be submerged. Now this tells me the equation that I have to use. What is the equation that I have to use for submerged objects? So in the first place, we have the situation. The situation for this exercise is the piece of metal in water or submerged object. Okay, that is what you do in the first place. Second, you choose the equation for the buoyant force. The buoyant force for submerged object is equal to what? It's the same that I wrote in the other exercise, okay? Because it's the same situation. Object submerged, then the formula for buoyant force is actual weight minus the apparent weight. So we're gonna have the actual weight minus the apparent weight. And you can get it from now. The actual, that is the weight in air, okay? It is 50 Newton. And the apparent weight, I'm going to focus in one situation first, okay? So I'm gonna be focused now in the second part, okay? Right now I'm working with the second part, the object immersed in water, because I know the density of water. If I work with the other exercise, I don't know the fluid, okay? So I won't be applying the equation. So right now I will be in metal. Well, this is the situation, metal in water, okay? So object submerged. So I apply the equation, the actual of the metal, that is 50 Newton, and the apparent, that is the weight in the water, 36 Newton. So this gives me a buoyant force of 14 Newton. Okay, after you get this, what do we do? What did we do in the last exercise? After the object submerged, after the buoyant force, what we did was getting
The useful formula.
the useful formula, okay? So the useful, the useful formula relates density and weight, okay? So density of the object divided by the density of the fluid equals the actual weight divided by the buoyant force. This is what we have in the useful formula. Okay, now we substitute by the givens and we isolate what we need to know. What do I need to know? I need to know the density of the metal, okay? And what is the density of the metal? Density of object or density of fluid?
Density of object.
Density of the object, so I'm gonna get it. So density of the object is going to be equal to the actual times, because it was dividing, the density of the fluid divided by the buoyant force that we just got. We just plug in the givens and you will have 50 Newton times the fluid. What is the fluid in this situation? It says metal in water. So density of water, that is 1,000 kilograms per cubic meter. And you will divide by the buoyant force, 14 Newton that you got before. Eliminate the newtons and newtons. And how much do you get? How much do you get?
3,571.43.
And you write the units that you didn't eliminate. That is kilogram per cubic meter. That is one of the answers I got. We'll finish this exercise on Monday. I will assign you homework related to what we saw this week. Okay. So don't have the time to do the other part. So see you later. Oh no, I cannot end the meeting from there.